Welcome back to the morning show. It's 7 minutes after 7. We're kicking back with the wise guy this morning. You make science so fun and relaxed. We just thought we'd get comfortable this time.
It's a really comfy seat, so I was going to have a little nap.
As comfortable as your socks, right?
These eggs, are these breakfast for us? Or
right, no, we did these in the first segment, and we had made one float by putting sugar in the water. But I just want to explain why something floats or sinks. When you put something in a liquid, there's an upward force on it called a buoyant force, which is equal to the weight of the liquid that it displaces.
Okay.
So if the weight of the liquid that it displaces is greater than the weight of the egg is going to pop to the top. If it's less, it's going to sink. And so here's where I get to bring out the balloons. Okay, so you guys can each have a couple of these.
Oh, now, it's like we're back at the state fair.
That's right. Now, the reason balloons float up in the air is that the stuff inside the balloons weighs a lot less than the air that's around it. Helium is a very tiny light molecule, so when you fill a balloon with helium, it weighs less than the amount of air that the balloon pushes out of the way. Mm-hmm. So because it pushes a bunch of air out of the way, basically the weight of the air that this balloon has displaced is the upward force that you feel on these strings. So you can figure out how much, if this thing had air in it, the weight it would have is about the same as the force that you feel this thing pulling upward with. So it's not very much for a balloon, but if you had 10,000 balloons or something and tied them to a lawn chair, you could probably go up in the air.
We were trying to calculate that in back.
Right, and so air actually weighs, if you had a cubic meter of air, it would weigh about 3 pounds or over a kilogram. And so that's quite a lot, actually. And the neat thing about that is if you picture us at the bottom of this big column of air, which goes way up to the top of the atmosphere, all that air that's above us weighs down on us, and that's what causes air pressure. And so we have a demo here where we're going to measure air pressure. We have these 2 empty halves of steel.
Do you want some help?
That's okay. I'm just going to pump the air out of this real quickly. Then you guys are going to see how strong you are by trying to pull these apart.
Oh, this will be a tough one.
Okay, so I'm going to just pump
a couple of muscle guys like us.
Yeah.
That's right.
You have another one of those to replace them when we break, right?
Yeah, you won't be able to break it. So I'm just going to pump only part of the air out.
Just to prove we couldn't break it.
Yes, right. Okay. So now, there's not much air on the inside, but there's still quite a lot of air pushing down on the outside. In fact, atmospheric pressure is about 13 or 14 pounds per square inch, as you pointed out. So now on every square inch of this thing, there's 14 pounds pulling in. So why don't you guys try to pull that apart?
Yeah, are you using half strength, full strength?
I'll use full strength.
Put it up a little in case you do get it apart.
Okay.
So you had to pull pretty hard.
You're trying to make us fall over.
That's right. Now you can do this at home with suction cups, because that's how suction cups work. If you just take a suction cup like this, which is a couple of square inches, and you stick it onto something, you have a...
It's pretty strong.
You can't get it off, okay?
Mom's going to love using the pie plate for that.
This thing, which is about 1 square inch, it takes about 14 pounds to pull that thing up. That's because that's atmospheric pressure. And if you take 2 of these things with your friend, you can do the same thing that I just did. You squash these together, and then you just try to get those apart, Robert.
And what does the saliva do?
Well, you cheated.
Well,
a little bit of saliva just gives a nice ear seal. So what happens is, when you squish a suction cup onto something or onto another suction cup, there's nothing left inside. When you try to pull them apart, there's a vacuum inside. There's nothing there, but there is air pushing outside at 13 pounds or 14 pounds per square inch.
So in keeping with this trend of fun science things you can do at home, we're going to be doing this again next week?
Yeah, so people can send me more suggestions. I got some great suggestions last time that I'll get to in a few weeks, and more ideas are very welcome.
Good chance to ask the wise guy why.
And there's an email for it, wiseguy@uiuc.edu, or you can send it to us at news@wcia.com. We'll forward it on to you.
Okay, Matt, thanks. And here, try and pull those apart. I couldn't get them. Let's take a look outside through our Champagne Skycam. Little life.